Great, thank you. Good morning, good afternoon, good evening to all. Thank you for your time and joining me today to talk about our IP strategy and roadmap. Today we're going to be going through three main areas. We'll be talking about the whys and the reasons to go IP. A lot of this comes from feedback from our customers, from all of you and others we've spoken to, as well as some of the things to look out for as we make this migration. Then we'll transition into the actual Grass Valley IP strategy, the building blocks that make up that strategy, and then discuss how one can migrate over time to from an SDI facility to an IP. And I should mention here, when we talk about IP, we are referring to essentially where you use SDI today. So we're not talking about necessarily file transfer or contribution, distribution, and so forth. It's sort of in the facility. All right, so let's get into this next section, focusing on the why go IP. There's four main areas we want to drill into here, one at a time, to talk about the real benefits that IP can bring to you. So let's go through these. First being the ability to leverage the pace of innovation in the IT world. This is certainly attractive to many of us. If you look at the market, and apologize for this slide, it's on the left-hand side, it's in billions, and that's the revenue from last year. If you compare the size of the market of just Ethernet switching, both on the carrier Ethernet and enterprise, it's about 100 times larger than the SDI router market, which is about a $300 million volume. So why is this important? Well, it tends to drive investment. And companies that participate in these markets need to make a profit, and so they size their investments based on the size of the market. And so a lot of innovation can occur as a result of that. Here's just one measure of that innovation, which is port speed, and we're comparing SDI to Ethernet. You can see over time, in the early days of the digital video industry, SDI clearly was, at higher bandwidth, which was necessary for, SD, standard definition, and as we moved up to HD, it was also there. But then Ethernet started to catch up, and it, as you can see now, is on a really more of an exponential curve. This is a logarithmic scale, so the increase in bandwidth at the port level is quite substantial, and a lot of this is a result of the investment that's been going into this technology. So we'd like to look at leveraging that. Another area is around this area of reliability. We know that in broadcast we need very highly reliable infrastructure, and we want to make sure not to take a step back as we move to any new technologies. In this case, if we look at the IT world and where IP networks, IT solutions are deployed, we see them across the board in the finance, healthcare, government, and science area, and apologize for that. It's an area that has, many of these industries listed here have extremely high requirements for uptime, similar to broadcast. And they have been able to leverage the technologies that exist in the IT world to yield that sort of reliability. We call it 5 nines, which means 99.999% uptime. And that translates to just a few seconds per year potential downtime. Another area that the IT industry has been leading is in this migration to virtualized software on cloud-hosted systems. So over time, the industry's been through a transition from dedicated hardware solutions to software on dedicated servers to virtualize software. And the reason they've done this is to accrue the benefits from cost reduction, both capital and operational costs. The other benefit that they receive is from the scalability, upgradability, flexibility that these types of infrastructures allow. And this is an area that also is of interest in the broadcast environment to be able to have that kind of flexibility. So if we were to look at where the IT industry is today, it's here in 2015, whereas the broadcast industry really in this area is lagging behind the IT industry. And so there's opportunity to take advantage of some of these advances. Now, that is not; those ideas are not sufficient to make a move. There are some other real benefits that we want to look at before we would decide that IP is the direction to go. Clearly, another area of interest is this concept of being format agnostic. As we have moved through the years in the television and media industry, we've gone through different format changes. From analog video to SD, with embedded audio, HD, 3G, and so forth. And many of us have lived through these various transitions. Each one of them required a new infrastructure, new router, new modular products, in many cases new cameras, production switches, et cetera. The challenge is it's quite costly and quite time-consuming to go through that process. Whereas Ethernet has the ability to separate out the content or the format of the data and the method of transport. So this allows you to have more of a bandwidth-focused infrastructure that you can use to deploy various different types of media or formats. And as we move to 4K, we believe that this is even going to be more important to have this, and potentially even 8K in some areas. In this area of reducing cabling, many of you, I'm sure, are very familiar with this, the burden of the sheer number of cables that exist in our facilities today. As we're talking about moving to 4K, right now the technology is requiring 4 separate 3 gig links, as you know, so that's a multiple of 4 on the number of cables we already have, which is substantial. If we think about a typical production facility in SDI, you could argue there's really 4 separate networks. Audio video, you have your real-time audio video routing or infrastructure. You have intercom that's distributed. You have Genlock that is going to the various devices, and then your control and file-based network, which today is primarily IP. Each one of these has their own set of cables. In the case of audio video, primarily it's 1 cable per signal. And so we have a lot. The majority of the cables lie in that area. So if we focus here first just to see what IP would give to us, on this next slide, we have a couple examples, 3 examples of kind of the traditional approach to a 3 gig camera, as well as a number of services. We'll just call them generic services, bidirectional. And so this could be between servers that have inputs and outputs, between production switchers, et cetera. So as you can see on the right, you compare to the reduction if you were to use IP through an aggregated link, such as a 10 gigabit Ethernet or a 40 gigabit Ethernet. So to do 12 4K connections bidirectionally to a production switcher would take 96 3 gig coax cables. You can do all of that with 1 40 gigabit Ethernet cable. So that's a 98% reduction. Now, in reality, as we've put together some systems and we're looking at what this would really take, you're going to see 30 to 70% in the real world. If you just look at the weight of that in the case of an OB truck, about 10% of the weight budget usually is used for cabling alone. So if you save 50%, that would be 5% weight savings that you could use for additional equipment. So there's some real tactical advantages by using this technology. Now, if we take this one step further, now we've reduced the number of cabling, we could argue, if we adopted IP, but we still have these 4 separate networks. So with the technology, it is possible to collapse this and have one fabric running these 4 different services. You would have a 10 or 40 gig link or a gig link in some cases that would support all these various formats. Now, in reality, so we call this the simplified view. In reality, you're not going to want to have all those same services on the same fabric that are competing for bandwidth. So you would normally want to separate those out logically into segments, normally called a VLAN. And so you'd have an audio-video, your intercom, Genlock, and control typically are not going to take up very much bandwidth, so most of it would be reserved for the audio-video segment. You're also going to want to put in some redundancy, and the technology that is available to accomplish this is well understood. As mentioned earlier, you may not need redundancy everywhere, but you can pick and choose for those key paths, or you could have a completely redundant fabric. So the end result is to be able to really reduce the number of the amount of cabling that we have and simplify our infrastructure. This last area we believe is probably one of the most important, and this is really what is driving a lot of investment, and some of the early adopters in this space have been looking at the flexibility they get from an IP, more data center sort of design. So to understand this, let's think about a broadcast plant first, a typical facility, and let's think about one that may start small. Let's say they just opened the doors and they buy their first router, they decide they're going to go big, and it's a 144 by 144 router. They've got a little studio, they're producing some content, and they're monitoring that, and they're playing it out to some clients. Then they, of course, need to edit, so they start adding editing stations, and maybe this increases. They also want to improve the final product, and so they have incoming feeds that they mix with their studio feeds, and before they know it, they've now run out of inputs and outputs on what they thought was a large router. So this is good in that they're growing, but it's bad because now they have to think about how to manage that shortage in infrastructure resource. So what do they do? Normally, someone like Grass Valley would come along and sell them a new router, and we'd be happy to do that. So now let's say it's a 256 squared router, and everybody is happy for a while. Pretty soon, the studio guy, the person managing the studio, says, I really want to control my own destiny. I want to have my own sources and destinations just for my studio, and then I'll connect back to the core router for cases where I need to edit, play out, monitor, get incoming feeds, etc. And then pretty soon, the person managing incoming feeds feels the same way, and so forth. You end up with this distributed architecture with tie lines, all controlled from some control system. The challenge here is it's a blocking system. And when we say blocking, we mean there's not enough resources to have every source go to any destination without consideration of the bandwidth I have available on my tie lines. So this is out of control, says the facility manager, the person managing the core facility router. And so he has an idea, and that's to get even a bigger router. And so this continues. Very disruptive, very costly, takes a lot of time to swap out these routers. It's good for the vendor, not so good for the customer. So we think about a data center. Let's look at a successful data center that has gone through a similar growth phase, where maybe they start small, they buy a little blade server, and they can incrementally add blade servers as the demand goes up. They connect between these blade servers for sharing of compute resources through a top-of-rack switch that has sufficient bandwidth to move the signals back and forth. This is also sometimes called an edge switch or a leaf. You can expand within a rack. And then if you want to go to another rack, you can then have an end-of-row switch or an aggregation or spine. And this would have higher bandwidth and then would connect across between racks, and so forth. You can then even go to a core, which would have the ability to expand this out to a very large size. And the beauty of this approach is that it's distributed, it's graceful, you can gracefully scale without, and what that means is you do not have to retire or pull out of service any piece of equipment here. You start and you maintain that, you just add to it. And it can be designed to be wire speed and non-blocking. So there's some real advantages to that architecture compared to our SDI routing, which is normally one large router with all the sources connected through a single wire for each source to a central router and then out to the destinations. Sometimes the cable lengths are quite large between these sources for larger facilities. What we find is a lot of the companies listed here that are now actually entering or have entered the media market or selling of video content and television content, they are based on these sort of data center models where they can scale quickly and they can add new services. They can take advantage of market opportunities that are presented much quicker than a traditional broadcaster has been able to do. And so this is one of the reasons why we see, we believe, a lot of interest in IP technology, because it forms the basis of this ability to be agile. So again, just to review, the benefits of this IT approach are you have fewer cables due to aggregation, as we showed. You have shorter cable runs because you can take your edge box and put it closer to the source and destination. You can scale more gracefully, which gives you business agility. So now, changing topics a little bit to some of the challenges. What are the speed bumps, we say, or the things to look out for when you go to IP? So let's focus first on switching performance. So if you compare an SDI infrastructure to an Ethernet infrastructure, there's a number of important differences. Specifically shown here in green on the SDI router is the concept of synchronous switching. Switching in the vertical interval has been a hallmark or a key requirement for many applications. In many cases, this is handled through synchronizing all the sources, but also having some buffer on various components in this infrastructure that would allow you to align to that reference to assure a clean switch. The control is what we call out of band, meaning it's controlled from an external controller. Whereas on the Ethernet switching side, it's best effort switching. It's very possible to oversubscribe or overload these switches. And if you're not careful, so as a result, they will buffer the outputs. They add memory on the outputs to avoid packet loss, and they're designed for a statistical loading. So they have bursty traffic coming in from large file transfers and so forth, and there's times where it's very quiet. The control is what we call in-band control, meaning all the information necessary to make a forwarding decision or a routing decision is included in the packet header. So there's some distinct differences there. Now, if we look at some of the requirements that we have in the IT or in the broadcast space, we definitely need guaranteed bandwidth. And that bandwidth is fairly consistent as we have streaming video and audio coming from our sources to our destinations. We need a very low latency, but probably more importantly, a consistent latency, which then enables vertical interval switching. And we want this broadcast-centric control, which basically means I'm telling the core fabric when to switch, and it's fully deterministic and understood. In the case of a COTS IP switch, and in this case, COTS stands for commercial off-the-shelf. I have I can manage the bandwidth if I understand that. I can use something called SDN, software-defined networking, which we will speak about later, to have a very similar control experience. I have very low latency, but it's not consistent necessarily. And there is no concept of vertical interval switching with an IP switch. So let's look at this one a little more detailed. If I now consider some of the key applications that I have in my facility, incoming feeds, live production environment, and a playout. Let's just take those three. There are others we could add. And how do they stack up in terms of these requirements? Well, a lot of these requirements really come back to the live environment where you really need that. And even in some cases in a live environment, you can tolerate the non-vertical switching in the core fabric or the router because there are devices downstream which will clean it up, such as a production switcher, a presentation switcher / master control, or a separate downstream clean switch. And so there are cases in playout and incoming feed where, because of frame synchronizers or master control presentation switchers, where it's possible to tolerate a non-deterministic switch. So then if we look at these one at a time, we would say that you could use a commercial off-the-shelf IP switch for incoming feeds because you're frame synchronizing those. On the playout side as well, typically you have redundant master control or integrated playout servers that are downstream that can handle a different kind of a non-deterministic switch upstream. In the live environment, as we said, because there's a production switcher, in many cases you wouldn't need this, but because it's live, you need backup. And rather than putting in another production switcher, you would use your router to cut to air directly. And in that case, you need to have accurate vertical switching. So wouldn't it be great if you could actually have a solution, and this is what we've focused on, a solution, flexible, which leverages these common off-the-shelf switches for all the reasons we've cited earlier, from bandwidth and cable reduction and so forth, while still providing a deterministic solution where required. So this is what we've been looking at. Another area to consider, to sort of a speed bump, is the migration. We don't want to rip and replace. We recognize that very few facilities would be classified as greenfield, meaning I can put a building in there. I have no constraints whatsoever on what equipment goes in. I start fresh. That's a rare instance in today's market. More likely, we feel like this fellow on the right who is constrained by the box that he's in. So metaphorically, we are constrained by our existing facility, the fact that we have to usually stay on air. And so any strategy, we believe, has to consider migration from SDI in a very incremental fashion without requiring major downtime. And, Grass Valley, and I will say the industry in general, has been through these transitions before. We've done the analog to digital transition, the SD to HD, et cetera. And we've been able to do this successfully through a series of strategies that we think need to be employed as we move to IP as well. In addition, our parent company, Belden, has been through this a couple of times. In the transition initially to Ethernet, which occurred back in the late 80s and throughout the 90s in the enterprise space, but also in the industrial area where we play, they've moved to an Ethernet infrastructure as well. So we have some experience in that area, and we believe this is important. The last would be around standards. So we think it's critical to avoid what has occurred in our power industry, where everybody has kind of their own flavor, their own ways of doing things, and it was developed this way because of the regional element. At the time that the technology was developed, there wasn't a requirement for cross-country consistency. We want to avoid this, obviously, and so we work closely with SMPTE and other standards bodies, IEEE, et cetera, to support standards, but also to drive them so that they work and make sense for our customers. And we've always been dedicated and focused in this area. To us, open standards are critical. We try to avoid proprietary solutions wherever possible. So now let's go to the second phase here, which is really what is Grass Valley's view and what are we doing about some of these opportunities. So as you could imagine, our perspective is from acquisition to play out. We have products that span this area, from our camera all the way to our integrated playout servers and our monitoring solutions, the goal being to maximize the business flexibility for our customers. We have some key pillars as we think about, as we've planned and put together our roadmap. The first is migration flexibility, to the point of being able to easily migrate from an SD to an IP solution, or an SDI to IP solution. We recognize we have to do that in existing facilities that are up and running 24/7, as well as Greenfield sites. We need a very flexible, agile infrastructure based on common off-the-shelf IP switching fabric, as well as a deterministic IP solution for those cases that we need that. 4K over one wire is also very important. We haven't spoken much about this, but as we move to 4K, we want to avoid the requirement to have 4 separate cables, as well as we would like to have a very scalable solution. And lastly, the control is a key element. So if you look at a typical facility with all the main products, where we do most of our interfacing here between cameras or replay, production switches, et cetera, most of these are connected directly to an SDI infrastructure. We have also another connection for file transfer and control, so we have these sort of two networks. Our goal here is to be able to collapse that and be able to have direct connection from our products via IP into a fabric, using generic common off-the-shelf IP switching where we can, TV-centric configuration and control solutions, but also having an eye towards a deterministic IP solution, which we're working on. So this is our overall vision, and the way that we get there, let's talk about standards first, and then the actual building blocks and the timelines there. So there's a number of standards that have been worked out with the SMPTE committees. 2022, there's a whole suite of those. The -6 refers to the uncompressed baseband SDI, essentially being packetized. We are adopting that first because it enables compatible workflow and has a very broad acceptance. Now, it has some limitations as well, but we believe it's a good first step. We will adopt the TICO lightweight compression technology. This comes from a company named Intupix, and it will be our first format that we'll support to enable 4K over one wire. Since 4K is 12 gigabits, we would like to be able to run on a 10 gigabit Ethernet cable, so it doesn't quite fit. TICO is optimized for very lightweight, low latency. Lightweight meaning it does not require a lot of computational resources on the base products. And this has been a challenge in some of the other compression technologies, such as J2K and MPEG. And there's a standard in process to standardize this technology. AES 67 as a next step also we believe is very important for a production environment to enable flexible routing through an IP fabric of audio. And so this sort of replaces MADI in a sense, sort of think of it as MADI over IP, but that is going to be a key element in all of our products to be able to support AES 67 in addition to 2022-6. And we also have our eye on other technologies that we have plans to develop at the appropriate time, such as J2K, Sony compression, the LLVC compression technology, and then other SMPTE standards as they evolve. And so we have designed our architecture to be very flexible through an FPGA strategy to enable us the ability to upgrade as we move forward. So looking at the key building blocks real quick, we have IP gateways, connected products, and a control system that we'll go through here. So on the gateway side, we're starting with the logical first step, of adding IP input boards, IP output boards to our routers. And so our 8500 series is a very popular enterprise class routing system that is modular, has input boards, output boards, crosspoint boards. So we've built this input and an output board, two separate, with 10 gigabit Ethernet connections. There's 3 on each board, which enable anywhere from 8 to 16, 8 inputs to 8 outputs, or have a roadmap plan to expand that to 16 HD outputs, or 8 3-gig outputs. And this would enable this sort of architecture where you have an island or a separate sort of IP section in your facility. The router can be the gateway between those and switching back and forth. So it's almost like a tie line in a way, but it enables in the same box this flexibility. And we also recognize that there are cases where our customers will have other solutions for their SDI routing which do not support that capability. So we've developed a highly integrated, lower cost solution for conversion between SDI and gigabit or an Ethernet. And so this is a multi-channel IP gateway, has 2 10 gigabit Ethernets. It's redundant, has redundant mode on those 2 outputs. So can support up to 11 signals initially that can be either inputs or outputs. And in a similar fashion, it acts as a gateway between these 2 domains of IP and SDI. The next area, of course, would be the critical area being having direct connection so that we don't require gateways on every device. We would want to have a direct connection to our cameras, replay, et cetera. So here's an example. With an eye towards migration, we've made sure that all of our base products that we sell today have a path forward to IP. In this case, you have the LDX camera with its base station, the XCU, has a cradle and then a modular device, the XCU, where the processing occurs. So all one needs to do is upgrade the cradle, which would have a 10 gigabit Ethernet fiber connection. And this can be scaled from just the video output to the complete production package of bidirectional video, intercom, audio, control, et cetera, as well as supporting this 4K over 1 wire concept as a phase 2 deliverable. The standard connection to the camera, that doesn't change. And we have traditional interconnection while transitioning to IP. So this is a common approach that we also have on our production switchers with our K-frame, which supports the Carrera and Cayenne products. We are starting with the expansion modules. So there's 4 expansion modules in our small frame, 8 in our large. So you can scale up to 32 bidirectional I/O, 3 gig input outputs in the larger frame, or 16 in the smaller. Obviously, keeping the larger format input output cards, but also in a phase 2, we have plans to have higher density IP connections in this larger format, which potentially up to 40 gigabit connections, as well as TCO. And lastly, we're going to be announcing at NAB all three of these and delivering in the summer. This is the K2 Summit server, which will also have an optional codec board with two 10 gigabit Ethernet ports for 2 channels. And this will maintain, we're keeping the SDI during the transition period and expandable up to 4 channels. The last area, in terms of building blocks, leverages a new product that we're introducing, the GV Convergent product, which is it's a complete system-wide management solution covering configuration, control, and monitoring of a wide variety of devices. As part of that, we are developing a module leveraging the technology and the ecosystem of the IP world called SDN. So it's Convergent SDN. It's as I said, a module fitting within the suite of applications that is the Convergent product. And it allows us to control IP switching in a very similar fashion that we're used to in the SDI world, using things such as OpenFlow, Open Daylight, APIs, RESTful APIs, etc. So quickly, we'll look at how this works. If we think again of a traditional IP switch, as mentioned, the data plane and the control plane are in the box. So there's no requirement for an external controller, and all the decisions are made to optimize for that box. Each box has its own configuration. Whereas an SDN IP switch logically has the control plane removed, and it's really just a data plane box. And we use a technology called OpenFlow. It's a protocol that is supported in the majority of the newer switches coming online that enables an external controller to write directly to the flow table to instruct the traffic as it comes in to take a certain path and flow in a particular way. We are also using something called Open Daylight, which has been an open source set of code that was developed by the IP industry's a consortium of the key companies, including Cisco, HP, and others. And there's a standard RESTful API that one can use to talk to that SDN controller. So this is essentially what we've done. We've developed an application using that API, bundled with the Open Daylight controller, open source code, and we are providing that as a module in our Convergent product. Now, the real advantage here, of course, is the ability to optimize your quality of service across a whole flow of data from one device to another, so you can optimize at a higher level. And as you can see, it's a very similar fashion to what we've been doing in broadcast for many years. We just didn't call it SDN, but it's an external controller talking to a box that is requiring that direction. The beauty of this now is we can live in this mixed world where we have SDI routers and IP switches and all controlled under this same umbrella called Convergent. You can also use the same control panels that we're used to, so there's no need to retrain our operators. So that's kind of a summary of our building blocks. How do we put this all together to migrate, which, as we said, was one of our key tenets, key pillars. I've mentioned some of it, but think of it as a simple three-step plan where you would begin to acquire native IP devices, cameras, production switchers, all the devices that we talked about, things that can output IP. You would then build IP islands, and you would have connections between those with the gateway products that we talked about. And at that point, you can begin to control using SDN, this hybrid environment with a single control environment. And then lastly, as you incrementally build over time, these islands, you keep adding them incrementally. Eventually, you will replace your entire SDI infrastructure and end up with a complete IP fabric with some legacy SDI components connected in through gateways as needed. So graphically, we show this again. Today's facility, two separate networks. You would begin to acquire products that support IP directly, and then, if necessary, you can convert those back to SDI if they don't also have an SDI output using a gateway. Then you would deploy GV Convergent and an IP island, and this could be anywhere. We're just showing it here in playout for an example. And then you would use something like the Envision NV8500 gateway, or here's another example of using a density gateway where you have IP fabric on your production side. And then lastly, over time, as I said, you would end up with a complete IP fabric with legacy SDI routing. And there will be areas, as we said, that will require deterministic IP, and this is an area that we are investing in, and you'll hear more about this in the future. So this is the kind of summary of where we're going. We have a glass-to-glass solution, which is probably unique in the market in that we contemplate all the way from acquisition to playout and monitoring. We're dramatically reducing the cabling through this technology. Mm-hmm. We're able to have much more flexibility using this sort of data center distributed model. And we're using familiar TV-centric configuration and control. So that's the quick summary of what we're doing. We look forward to meeting with you at the show. We'll be introducing and launching many of these solutions at NAB, and we'd encourage you to stop by. We'll be having a lot of these products on the show floor that you can look at, and we'll be happy to answer your questions there.